Why does so much of the world's oil come from the Middle East's deserts? It's a question that has fascinated scientists, historians, and economists for decades. The answer is not just about what lies beneath the sand, but also about the incredible journey our planet has taken over millions of years. Beneath the endless dunes lies crude oil, often called black gold, a substance that powers our modern world, fuels our vehicles, heats our homes, and even forms the basis for countless everyday products. Countries like Saudi Arabia, Iraq, and Kuwait are world famous for their vast oil reserves. But how did these dry, arid lands become so incredibly rich in petroleum, while other regions did not? The answer is buried deep in Earth's history, beginning millions of years ago, when the world looked very different from today. To truly understand, we must travel back in time to an era when vast, shallow seas covered what is now desert. These ancient oceans teemed with tiny sea creatures and plant life, forming the foundation of a remarkable transformation. Over eons, as these organisms died, they settled on the ocean floor, becoming buried under thick layers of sediment. Immense pressure and heat, acting over millions of years, slowly transformed this organic matter into the energy resource we depend on today: crude oil. The gasoline in our cars, the diesel that powers trucks and ships, and even the asphalt beneath our feet all start as crude oil, refined from this ancient treasure hidden deep within the earth. But why is so much of this oil found specifically in the Middle East, and not in every desert around the world? The earth is always changing. Continents drift apart, oceans appear and vanish, and mountains rise and erode away. These powerful forces have shaped the land for hundreds of millions of years. The Middle East wasn't always a desert. Long ago, it was a lush, fertile region, shaped by ancient seas and shifting tectonic plates. Its current form is the result of powerful geological forces and dramatic climate changes. Understanding these forces, how the land shifted, how seas came and went, and how organic matter was trapped and transformed, unlocks the secret of the region's incredible wealth. So, let's begin our journey by exploring how oil forms, a fascinating process that turns ancient life into the energy that drives our civilization and shapes our world. The story of oil is truly the story of our planet's transformation, a tale of time, pressure, and the incredible power of nature. Let's dig even deeper into the origins of this remarkable resource and uncover the secrets hidden beneath the desert sands. Crude oil is a fossil fuel, a natural resource that powers much of our modern world, but its origins are ancient, stretching back hundreds of millions of years. It is born from the remains of ancient ocean life, tiny organisms that once filled the seas. Millions of years ago, plankton and other microscopic creatures thrived in vast, sunlit seas, forming the base of the marine food chain. When these organisms died, their bodies drifted down and settled on the ocean floor, joining countless others in a thickening layer of organic debris. Over time, layer upon layer of sand and silt buried this organic material deeper and deeper, creating immense pressure and heat as the weight of the earth pressed down. This slow-cooking process, lasting millions of years, transformed the buried remains into a waxy substance called kerogen, and eventually into hydrocarbons, crude oil, and natural gas. Oil and gas, being lighter than the surrounding rock and water, began to migrate upward through tiny cracks and porous rock layers, searching for a way to escape. Their journey stopped when they encountered impermeable rock layers, which acted as a cap, trapping the oil and gas in porous underground reservoirs. These hidden underground pockets are what we drill for today, tapping into the Earth's ancient energy reserves. The transformation from simple plankton to valuable oil is a process that can take up to 150 million years, a timescale almost impossible to imagine. The right conditions, abundant organic material, intense pressure, sufficient heat, and a solid cap rock were all essential for oil to form and accumulate. Without any one of these crucial elements, oil would never have formed, and the world as we know it would be very different. This is the hidden story beneath the world's great oil fields, a story written deep within the earth, over unimaginable spans of time. The Middle East's unique geology provided the perfect recipe for oil formation, with vast sedimentary basins and ideal conditions. That's why the region became the world's oil powerhouse, shaping economies and societies across the globe. Not all fossil fuels are created equal. Oil and coal are cousins, but their origins differ. Oil comes from marine plankton buried under ancient seas. Coal forms from giant plants in swampy forests. In the Carboniferous period, vast forests covered the land. Dead plants fell into oxygen-poor swamps, slowing decay. Over time, pressure and heat transformed this plant matter into peat, then lignite, then coal. Oil's source is ocean life, coal's is land plants. That's why coal is found in places that were once forests, like North America and China. The Middle East, once a sea, is rich in oil, but has little coal. Both fuels store ancient solar energy, released when burned. Burning fossil fuels releases the sunlight captured by plants and plankton millions of years ago. The Middle East's lack of coal and abundance of oil reveals its watery past. Its geology shaped its energy destiny. Understanding these origins explains the world's energy map. To find the Middle East's oil source, look back 250 million years. Then, a supercontinent called Pangaea surrounded the vast tropical Tethys Ocean. The Middle East was submerged beneath these warm, shallow waters, perfect for plankton to thrive. For millions of years, their remains settled on the seafloor, mixing with sand and mud. The Tethys had many basins with low oxygen, preserving organic matter from decay. Thick layers of organic-rich sediment built up, starting the oil-making process. The Tethys Ocean was a gigantic oil factory, collecting raw materials for eons. Its unique geography and conditions made it ideal for oil formation. The land that became Saudi Arabia, Iraq, and Iran sat at the heart of this ancient sea. Over time, these sediments became the foundation of today's oil fields. The Tethys's legacy is the Middle East's oil wealth. Its watery past shaped the region's future. Earth's surface is broken into tectonic plates, slowly drifting atop the mantle. Around 100 million years ago, Africa and India moved north, closing the Tethys Ocean. The Arabian and African plates collided with Eurasia, squeezing and folding the seafloor. This collision created mountain ranges and folded rock layers, perfect traps for oil and gas. The Tethys Ocean shrank, leaving behind the Mediterranean and Black Seas. The former seafloor became the Arabian Peninsula, with oil and gas trapped beneath. Plate tectonics didn't just create land, it concentrated the region's oil wealth. The Middle East's geology is a product of this ancient collision. The Middle East covers just 3.4% of Earth's land, a surprisingly small slice of the planet. Yet this region holds nearly half of the world's proven oil reserves, a staggering concentration of energy resources in such a compact area. This fact alone has made the Middle East a focal point for global attention and competition. Saudi Arabia alone accounts for 17% of global oil reserves, making it the single largest holder on the planet. When you add in Iran, Iraq, Kuwait, and the UAE, the numbers climb even higher, cementing the region's dominance in the oil world. These countries together form the backbone of global oil supply. But it's not just oil. The Middle East also holds about 40% of the world's natural gas reserves, making it a powerhouse for both major fossil fuels. This dual abundance has amplified its strategic importance. The South Pars, North Dome Field, straddling the border between Iran and Qatar, is the largest natural gas field ever discovered. Its sheer size is almost unimaginable, fueling industries and economies far beyond the region. This extraordinary concentration of hydrocarbons has shaped not just the region, but global politics and economics for over a century. Oil discoveries here have triggered booms, conflicts, and alliances that continue to influence the world today. By comparison, the US and China are much larger in land area, but have only a fraction of the world's oil reserves. Their energy security often depends on what happens in the Middle East. The Middle East's unique geology made it the world's energy epicenter. Beneath its deserts lie vast, ancient deposits formed under perfect conditions. Millions of years ago, the right ocean covered the region at just the right time, while tectonic plates shifted and created the perfect traps for oil and gas to accumulate. Nature's timing was impeccable. It's as if the Middle East won a geological lottery, with the winning numbers drawn over millions of years of Earth's history. The region's oil wealth is no accident. It's the result of a rare combination of geological events and conditions, all coming together beneath the desert sands. This remarkable history explains why the Middle East continues to wield such global influence, shaping the destinies of nations near and far. The story of oil is written in the rocks beneath the desert, a story of chance, time, and the forces that shaped our modern world. Why doesn't every region have as much oil as the Middle East? 4 unique factors came together in the Tethys, a warm, shallow sea teeming with plankton, low oxygen basins preserving organic matter, thick reservoir rocks capped by impermeable layers, and gentle tectonic folding to trap oil. Other oceans lacked one or more of these ingredients: too cold, too deep, or too much decay. In many places, oil escaped or never formed at all. The Middle East's salt layers are especially effective at sealing in oil. Elsewhere, tectonic activity was too violent, destroying potential oil fields. The Tethys region experienced a just right collision, gentle enough to trap oil, not destroy it. This rare combination made the Middle East uniquely rich in oil. Geology, not luck, determined its fate. That's why the world's largest oil fields are here, and not everywhere else. Oil took millions of years to form, but we're using it up in just a few generations. It powers our world, but it's a finite resource. Once it's gone, it's gone. Global demand keeps rising, while new discoveries are smaller and harder to reach. Sooner or later, oil production will peak and decline. This raises tough questions. What happens when oil becomes scarce and expensive? Burning oil also drives climate change, releasing greenhouse gases and polluting our air. Oil spills and extraction damage ecosystems and human health. The world is realizing we can't rely on oil forever. Our dependence is risky for the economy, the environment, and our future. Change is not just necessary, it's inevitable. The search for alternatives is reshaping our world. We're transitioning from fossil fuels to clean, renewable energy. Solar and wind. Solar panels and wind turbines now generate cheap, clean power without emissions. Renewables offer energy security and economic opportunity, creating jobs and reducing dependence on imported oil. Even oil-rich Middle Eastern countries are investing in solar, preparing for a post-oil future. The journey from the Tethys Ocean to today has fueled progress, but now we see the costs. Embracing renewables means a cleaner, healthier, more sustainable world. Understanding oil's story helps us value it and move beyond it. The future of energy is as enduring as the sun and wind.